Okay, so let's continue from where we left off in the last video of the Intro to Artificial Intelligence series. In this video, we are going to take a look at problem solving. Recall the problem that we discussed in the previous video about the different paths that are available for us to take when going from one point to other. So let's discuss how we can solve this problem through a very integral part of overall AI, which is problem solving through searching. So let's take a look at the components of problem solution, where of course the first step in problem solution is the goal formulation, and then of course problem formulation, which we studied in a little bit of detail in the previous video. They are the actions to consider given a goal. Then comes the solution itself, which is the sequence of actions to achieve the goal. After finding the solution, the agent executes the recommended actions of solutions in order to solve the problem. When we are designing an agent, it's important to consider the base design or the structure of process that is going to follow. That usually depends on the problem you are trying to solve. And in our case, all we need our agent to do is to formulate the problem intelligently and search for a possible solution and then execute the solution actions. Notice for now, we are just trying that the agent solves the problem instead of giving us the best possible solution, and that would be more intelligent for it to do. But we will take a look at getting best possible solution in the future when we study more about searching. For now, all we need is coming up with a correct solution to a formulated problem. Okay, so we are almost on our way to start solving the pathway problem. We know some terminology that we use while making an agent program. Now, don't get me wrong, we haven't started making actual agent program, but even when discussing in terms of pseudocode, there are some terminologies we should be familiar with for an agent trying to solve a problem. And of course, this is something we very briefly mentioned while studying problem formulation part in the previous video. So the first one is the initial state. It's the starting state of an agent before the start of problem solving. So like in our problem, we start from the area of Arad, and that is the starting state in our case for the agent. Then comes successor function. In an agent program, a successor function is a function that returns two strings. The first one is the action, and the second one is the successor. Action is the next possible action that can be performed by agent in the current state, and the successor is a state in which the agent comes in result of performing that action. So it's a pair of an action and a successor state. So I want to explain a little bit about how a successor function works in theory. So going back to our main problem of our autonomous vehicle going from one place to other. First, we have the initial state of in Arad. Then we have many possible actions, but let's, for the sake of argument, take the action as go to Sibiu. And when we put these two things into a successor function, what it does is it returns the current state, which is now in Sibiu, and any possible actions that can happen from Sibiu, which could be, for example, go to Faragus. And so this function plays a super important role in agent to solve the problem. So looking back at the terminology, one last thing before moving on to the actual solving via intelligent search, we have the state search, which basically is set of all states reachable from the initial state. And it's implicitly defined by initial state and successor function. So successor function gives us all the actions that lead to all the possible states from the current state of the agent. So you can see sort of where we are going with this. From Arad, the possible states of an agent can be in either Zerind, Timisoara, or Sibiu. Sorry, I can't pronounce the names correctly. And for example, if you go to Sibiu, the possible states are Oradia, Arad, Faragus, and Rimnisu Velia. And the availability of this information allows the agent to solve the pathway problem. But for now, the issue is that the agent does not know which is going to be the correct path. And for that, we have to take a look at some algorithmic sort of techniques, such as performing tasks with control and restrictions, so that it always returns in some action that leads to the correct solution of the problem. And for that, we have the concept of search trees. A search tree is a form of representation of state space. It combines initial state and successor function as nodes, where each node is a state and there are other nodes connected with it, which represent the previous or next state for each action resulting from the successor function. Okay, so that was probably a bit complicated to understand. So let's study what searching in its essence. But know that searching is not about maps. That's just an example. Searching is about the different choices that we can make while solving a problem. Let's just dive a little deeper into it. Okay, so search strategies. There are different methodologies that we can use in programming our agent to search for the solution for a given problem. The first one is the uninformed search. It is a strategy to find a solution and not the best solution. Uninformed search is the first one we are going to study. This strategy yields just any solution, a solution to the problem that seems correct, but no sense of whether or not the solution is better, good, or inefficient. So next up we have informed search, which is based on how near the node is to the goal. Or in simpler words, we can say this technique depends on finding actions that bring us more closer to the goal. In this way, we are able to solve the problem in fewer steps. Then we have the optimal search, which depends on finding the solution path which costs us the least resources. In terms of computer science, it is also referred to as efficiency or complexity. Alright, so uninformed search itself has two strategies. The first one being the breadth first. Look at the image on the right. This looks familiar to the example shown before. We have to reach from S, the initial state, to either G or E. These are the final states. So we draw a search tree. Take a look at image on the left. Starting from S, we go to each possible states from S. That were A and B. And breadth first basically means for each node of a parent node. Parent node is S here and its child nodes are A and B. So for each node, we calculate the possible actions or paths one by one. So breadth wise. So after A and B, we have to go to the possible nodes from A first, which are A and D. Then we expand the possible pathways of B on the right, which are A and C. So going just like that, now let's expand B from the left, so we get C. Then expanding D, we get G. So we have already searched and found the solution at this point. But continuing just like that, expanding A again, we get D, and expanding C, we get E. These are the end states, but you see the only two states of solution that we wanted was either G, actually preferably G because that's the first solution we got, and E as well. So the problem occurs when we are extending nodes unnecessarily, and to solve that, what we can do is we already have some extended nodes in memory, and if we extend them again by calculation in the future, that would take more memory, where we can use the stored expanded node that was done before. So we eliminate any further extension of nodes if they are already previously expanded and don't use them because they don't lead us to the solution. Okay, so I think this should be enough for this video. We will take a look at depth first technique, which is the second strategy of the uninformed search, in the next video. And so with that being said, see you all in the next one.